Thank you very much. Thank you very much for this kind introduction. My name is Daniel. I'm team lead at Junie team at JetBrains. Today, I'm happy to be here to share with you our motivation behind our Junie coding agent and to share with you the strategy of us competing at this very hot and very competitive market of AI coding agents. Let me start with a very brief intro of myself. I have a background in ML engineering, and I'm in the industry for more than 8 years. Before JetBrains, I worked mostly on large-scale recommender systems in the biggest Russian IT companies. Now, obviously, I'm here in Belgrade at JetBrains doing Junie coding agent. And to start with, I would like to try to settle everyone on the same page. Please give me a favor. Raise your hand if you have used ChatGPT for your work-related tasks at least once. Wow, a lot of people, thank you very much. You're a very well-prepared audience for this talk. I feel much safer here right now. So let's go and see, how do we usually use ChatGPT for coding? We can, this is something very important to be said upfront. So trust me, coding agent is absolutely not a magic. Coding agent is just a transparent, simple tool that could help to resolve your tasks faster. And let's go and see, how do we interact with ChatGPT for coding, and what does it have in common with coding agents? So we can use ChatGPT for coding, for example, as follows. We can say, hey, ChatGPT, I have Google stock.csv with historical data on Google stock prices. Please write code to calculate relative difference between 2023 and 2024 prices using Python. And ChatGPT is here to help us. Here you go, some explanation and some code that we're expected to copy-paste, run, and get the result. We follow the instructions, and as usual, we get some error. OK, we're copy-pasting the error back to ChatGPT, saying, hey, ChatGPT, I have a problem. There is an error. And ChatGPT is, of course, here to help us again. Do step 1, run this code, then run this code, and everything will get fixed. OK, we're starting to follow the instruction, copy-pasting the code, running it, and getting a very unexpected output on the very first step. We're saying, hey, ChatGPT, I'm getting some very unexpected. Are you sure that it's OK? ChatGPT says, hey, now I really know what's going wrong. Please use this code and you will succeed. We're using this code, and as you can expect, we do not succeed. We get error again. We copy-paste the error again, and ChatGPT is again ready to help us, and we copy-paste this code, run it, and finally, stuff is working right now. I think that many of you actually recognize yourself in this kind of pattern of interaction with ChatGPT. And a very important thing, by the way, to understand that essentially coding agent is nothing more than just efficient and smart automation of this copy-paste and execute pattern. It's a very important thing to understand today, in today's world of crazy marketing and crazy hype around this topic. And to kind of make you even more sure that I'm actually true, let me show how Junie will tackle the very same task. So hopefully this video will work. I have rehearsed it 3 minutes ago. Yep, it's working. So we are asking Junie to do a very same stuff. And Junie is working right now. Junie is working on creating a Python script. Here you go, Python script is ready. And now Junie will ask whether it's OK to run the script. Of course, running any code is potentially a harmful operation, and any coding agent will ask you before running. So we accept. Junie run the code, and as you can see, there's some problem. And Junie tries to fix the problem, tries to edit the code again. Tries to edit again and again. Now it's working a bit, providing current status, what's going on right now. Asks to run the code again. The code is run. Again, some problem there. Again, Junie is working on making some fixes. And by the way, if you will read this gray text, you will notice that the errors are very, very similar to what we've seen when we have done this manually. And what is the reason? Guess what's the reason? Of course, the reason is that Junie essentially does very, very same thing that I showed before, but in automated fashion. As you can see, now the script runs successfully, and Junie is working on the final report, and here is the final report. So as you can see, this is just automation, of course, smart automation of what we are doing with ChatGPT ourselves. And I really hope that by this short introduction, I can reveal this magic aura around like AI coding agents. But still, I guess that you could potentially have some additional questions. And let me spend a little bit of time to try to guess those questions and answer them up front. The first question you could probably have is the following. LLMs, large language models that are essentially backbones for AI coding agents, they usually output text or images. How can Junie run commands on my computer from my behalf? And that's a fair question. Let me provide you a quick explanation. LLMs are very smart tools. They are smart in instruction following, which means that we instruct LLM to do something, and usually it will strictly follow our instruction. And we can use it in the following way. We can ask LLM, please format each your response like this. Include thought tag, where provide some motivation of what you are doing, and command tag, where provide the exact command that we need to run. And LLM will behave accordingly. It will provide responses in this kind of fashion. And we can parse this and render thought as an explanation for user and take a command and actually run it on the user's machine. Just as simple as you see here, no magic. Of course, as you can imagine, this scenario of using LLMs to run something is very popular nowadays. Because of that, LLM vendors tend to use their own custom formats. Those formats are usually referred as to-use or function calling. Those formats are very nice because they are exposed to model even during model training. And because of that, LLMs feel kind of more convenient when using these formats. But again, nothing special or nothing magic there. Just predictive way of formatting the LLM outputs. And that's it for executing commands. Another question that you could probably have is the following. Well, LLM can execute commands, but how can LLM efficiently edit very large, very long code files? A fair question again. Let me provide an explanation. Let's imagine we have a very long file. Let's imagine it has 10,000 lines of code. This is a small fraction of that. And let's imagine we need to add a comment here. How will LLM do this? Of course, generating the entire file with adding comment is totally bad idea. But what we can do instead? Let's recall that LLMs are smart in instruction following. And it happens that they are as smart that we can even define custom commands for LLMs. And LLMs, if those commands are properly described, will be able to use these commands. OK, let's go and define replace lines commands, which will accept file name, start line, end line, and the new code. And description will say that this command will replace code from start line to end line in the file name by the new code. And by providing such instruction to LLM, we will LLM make to edit code with this kind of command. And our LLM, our agent, will generate something like this, replace lines module by 458, 458, then goes the comment that we want to add, and then goes the original 458 line, because we were to add the comment, not to delete this 458 line. And here will be the result. Of course, obvious thing, when we are defining command for LLM, it's totally our job to do both, to describe command for LLM and to actually implement this logic. This logic is to be implemented on the backend side, on Junie backend in our case. So Junie backend has to receive this call to replace lines, to parse it, and to actually make it to edit user's code. As you can see, again, very simple engineering and no hidden magic. At this point, I really hope that this magic aura around coding agents is almost totally revealed. And we are ready to proceed to the next section of the talk, which is about Junie. So Junie, the coding agent by JetBrains. But why Junie is special? What is the difference between Junie and Junie's very good, very nice, and very popular competitors. Let me share with you the strategy behind Junie. First of all, we consider professional developers as the first-class citizens for Junie. Vibe coding for fun goes next. Sorry for that. Then, Junie must be good now, today, not in future, when AGI, when better LLMs, and so on. Then, Junie must take care of collaboration, your human-to-agent collaboration, to improve the final result. And the core of our strategy is benchmarking. We take it very serious to measure our progress, to ensure that we are going towards the right direction and that we are not making wrong steps. And I quite understand that for now, this could sound like a set of slogans. But give me a moment. I will dig into the details about each of these points, and you'll understand that those are not just marketing bullshit. Each of the bullet points is a design choice that we actually made while developing Junie. So let's go on. What do I mean by professional developers being first-class citizens for Junie? I mean roughly the following. Build me an AI agent for trading, or build me a snake game in browser is not our focus. And what is then our focus? Roughly this. If user has network connectivity issues, the cause behavior on our site, C-class user cart info, could be unexpected. Ensure that users can't add items to the cart once offline, and add graceful error message when user tries adding item to the cart while being offline. This is roughly our focus. What is the difference, you could ask? Well, the main difference is that the latter addresses the existing and potentially very large and very complex project. We strongly believe that in 99% of cases, professional developers deal with something on top of existing and usually large and complex code bases. And because of that, we consider this use case as our main focus. Greenfield development, like build me something from scratch, is very nice for fun, very nice for marketing, for advertising, but it's not as useful in practice for pro developers. And we are really focused to help professional developers to do their job faster and with more joy. So that's it. What do I mean then by Junie being good now? I think everyone noticed that LLMs are improving rapidly. And in this world of rapidly improving LLMs, it could be a viable strategy to just create a coding agent somehow and wait until LLMs improve. And by LLMs improvement, we will get better coding agent automatically. It's a viable strategy, but it's not our strategy. Our strategy is about having a solid ML team, a complex benchmarking system, I will cover that later, to really get maximum from the LLMs we have today. And we are really fighting hard to get those, that's something that is called our improvements here, like 5% improvement. Although we quite understand that in several months, there will be a release by OpenAI, Anthropic, or whoever with a new model that will provide us even more improvements, say 10% improvement almost for free. And then we will again fight for those additional, say, 5% that we can get from that model, and so on and so forth. Although these, our improvements, are less than improvements by LLMs, we consider them very important, and we consider them as our competitive advantage. Then goes collaboration stuff. This thing, I would like to start with asking a question. Why do you think usually AI coding agents are less smart than human developers? Of course, could be many reasons for that. But the most important reason, in my opinion, is that coding agents do not have this. And they even do not have this. You communicate to your colleagues a lot on meetings, coffee points, lunch, Slack, email, etc. And you naturally share a lot of useful context. LLMs and coding agents naturally lack this context. And usually, when thinking about this problem, folks are tending to think about embedding your Jira, your Slack, your email, your whatever into coding agent. And of course, it makes total sense. However, there is something, in my opinion, kind of overlooked here. which is ability to ask proper questions in proper moments. Also, it is ability to decompose complex tasks into simpler ones and to understand which task is complex. And of course, it is about memory, ability to store and manage this long-term context. This slide is mostly future-looking, and it's future-looking for us both as Junie team and as AI coding agents community. And if you were attending this talk to understand what's the next big thing for Junie, well, the answer lies somewhere around this slide. And we're going further and approaching the core of our strategy, which is benchmarking. To start discussing benchmarking and its importance, I would like to share with you a real-life example. We faced this example several months ago when developing Junie, and it's not as hard to understand, and it highlights really nicely the importance of benchmarking for improving coding agents. So here is the example. If you have used JetBrains IDEs, you are probably familiar with the rename refactoring tool. It's a tool that can rename entities in your code along with all the references with a single action. It's a very convenient tool. It's a lifesaver for bigger projects. And of course, we want to equip Junie with such tool. And okay, let's remember from the beginning of the talk that LLMs are smart enough to use custom commands. So let's go and define custom command, rename, which will accept file name, line number, old name, and a new name. And the description of this command will say that this command will rename old name to the new name, old name, which is in the file name and the line number, will be renamed to the new name, and all the references of old name will be renamed automatically as well. Okay, we are done with describing the command. We are done with implementing the logic of this command on the Junie backend side, and now we are ready to play around with Junie, to ask Junie, please rename me something to something, and see what will happen. So here is what we observed. First of all, Junie says, okay, now I'm going to search for all the references of this something, and starts reference search. Then Junie says, okay, I'm done with the reference search. Now I'm ready to call rename, and calls rename. And then Junie says, okay, rename command succeeded. Now I need to go and search all the references again to really make sure that they are renamed. As you can see, this very simple task that should have taken 1 or 2 steps takes actually many steps, many additional non-necessary steps. And of course, it's not something we can tolerate. We need Junie to be able to efficiently use IDE. So we need to improve this behavior somehow. And let's think a bit on what means do we have to influence the agent behavior. We have quite some ways, and let's discuss them. First of all, we can try doing something with primary model, with our LLM. We can try using another model, for example, or we can try fine-tuning if it's available. Also, we can go with prompting. We can change somehow system prompt or global instruction for LLM. Maybe adding some additional instructions for renaming, maybe adding some examples there. Also, as a subset of prompting, we can change rename command description, maybe add some examples there. And finally, we can even change rename command output. Again, remember the beginning of the talk when we were using ChatGPT. We were copy-pasting the errors back to ChatGPT. Obviously, coding agents do the very same thing, but not only for errors, for successful outcomes as well. And since renaming is our custom command, we can provide any additional instructions to the output of this command, and they will be fed into LLM. So here are the ways we can try to improve the agent behavior, and let's go and do this. Let's make Junie to use renaming efficiently. Usually, these kind of improvements follow roughly this kind of pattern. We are starting with a mostly or always bad status. What it means in our case, it means that almost always when we ask Junie rename something to something, we have many additional non-necessary steps. And it happens that usually with simple prompt experimentation, with just a handful of examples, we can easily travel to the next sometimes bad status. What sometimes bad mean? Sometimes bad is when generally things kind of work. Usually you ask Junie, rename something to something, and it does it with a reasonable number of steps. However, sometimes, say 20 to 30% of cases, you still have those unnecessary, nasty additional steps. And we, of course, want to go further to the mostly good status. And unfortunately, here problems begin. Oftentimes, it's not enough to do 1 or 2 changes to travel from sometimes bad to mostly good. Usually, covering this route requires a sequence of small steps, of small improvements. And what is small improvement and what's the problem with this? Small improvement could be, say, 5% improvement, and 5% is 1 per 20. And unfortunately, you will never be able to see this 1 per 20, 5% improvement with just manual debugging. So here you absolutely need benchmarking and proper metrics measurement to be able to measure those small improvements. And realistically speaking, even for the first step, we also need benchmarking. The reason for that is the following. Of course, renaming is not the only task that agent could do should do efficiently. We are interested in many types of tasks. And it's very important to ensure that any change to the agent does not degrade quality on any types of tasks that we are interested in. Even small, like 1 or 2% degradation is intolerable. So we absolutely have to use benchmarks for control as well. So what was the benchmark for rename refactoring? It was a small benchmark of just 35 tasks. Each task is a Git repo and rename something to something task. Junie tries to resolve this autonomously and provided some patch. Then, each of the tasks is equipped by hidden tests for automatic correctness checks. And regarding the metrics, for this simple case, 2 of them are absolutely enough. It is a resolved rate and average number of steps. And by this done, we actually unlock for us the opportunity to measure these small improvements and to make a series of small steps from sometimes bad to mostly good status. And that's it for rename refactoring example. Generally speaking, Junie benchmark consists of tasks. Task is problem description and some real-world project on which this problem should be resolved. Junie tries to resolve the problem autonomously, and then human-validated tests are used to evaluate the solution. If we take 100 to 300 such tasks, we get more or less standard benchmark that we are using. And if we run this benchmark, we get a lot of logs that are used to find insights on bottlenecks, on potential improvements, and to calculate a lot of metrics about the agent. Here, I must mention notable researchers from Princeton University that suggested a convenient and more or less scalable way to collect such benchmarks using GitHub issues and GitHub pull requests. Their approach has a number of really critical limitations. However, it's very widely used in the industry, and I would say that this approach really fuels the coding agents industry nowadays. If you're interested for more details, please scan QR code. If you are interested to discuss the limitations, you are very welcome. I can speak a lot about this after the talk. So, by benchmarks, we cover, of course, all the programming languages that we really care about, and all the task types that we really care about, which is regular coding, which is refactoring, ask mode, which is some questions about repositories, follow-up tasks, terminal tasks, and some other types of tasks. And by running benchmarks, we find improvements by analytics on top of the logs of these benchmarks. We accurately assess each individual change to the agent to ensure that we are not making wrong steps. We are not degrading somewhere. We are really moving towards right direction, and we are not overfitting to the handful of examples, which could easily happen if you will try to improve coding agents using manual debug and like 3 to 5 examples. And to do all this stuff, we have a prominent ML engineering team. It's 9 people featuring 3 Kaggle Grandmasters and 2 Kaggle Masters. Those folks are responsible for getting maximum quality from today's LLMs and from tomorrow's LLMs as well, of course. To ship that quality and those improvements to the product, to users, we have a notable software engineering team. And of course, QAs to ensure that we are shipping a good quality product. And that is Junie development team. And the takeaways of today's talk. If you are a developer and if you are using ChatGPT, try Junie. I think you will like it because we are professional developers creating a product for professional developers. And here is a nice real-world demo of Junie. Usually I do not like demos of coding engines because they are about create me snake game in browser. But this is an exception. This closes a feature request in a real-world GitHub open source project. And you can check it out. How does it work? You can check the pull request. It's under review right now. So it's a real demo of how does Junie work in a real environment. Here, I would like to thank you all for your attention, and I'm happy to take some questions.
So if you have any questions, we have microphones in the room. No, raise your hand. There is one hand raised here. Let's move fast. Another one. Okay. Oh, and I'm so glad to see you're healthy again. Things are happening at this conference that you don't know about, hauntings and more. And if we run over time, not a problem. Can you come a little bit in the center so people can see you? This is what the man looks like, okay? Good.
Hello. Okay, can you hear me? Okay, I have a question in regards to what you said to the try-check loop, where you try something and it doesn't work, then run checks, and if those checks fail, then make some changes again. And so how do you prevent from wasting a whole bunch of credits in a whole lot of attempts that do not produce successful result? Or either how do you prevent, because LLMs sometimes tend to oversimplify the solution if they can't get a proper solution. So how does Junie tackle those situations?
Yeah, that's a nice question. So general approach is analytics on top of benchmark logs. So it would be a really oversimplification saying that we are just interested on the score, like result rate on the benchmark. We have a lot of different metrics that as well cover the things that you are asking about. Regarding agent making some step again and again and again without success, we observe that ability to ask user really help. So if we provide agent the ability that you can ask user if you are stuck or whatever, LLMs usually use this. When it tries 1, 2 times, it doesn't succeed, okay, it will go and ask you, and it kind of works.
Thank you.
I guess, but I guess you can hear me. I'll speak up.
Yep.
A question about Junie's speed. I've been using some of the other agents, and sometimes you're just like sitting and waiting. Come on. Are you optimizing that as well? There's some other competitors release some. Oh, this is a very fast model now, but very quick. I haven't tested it, but like this kind of iteration speed. Is my question.
This is a very interesting question that we are actively kind of discussing internally. Obviously, there is a trade-off between speed and quality. And I would say that Junie is mostly on the kind of quality side right now. But we are thinking on the better way to providing user to kind of tune this trade-off. Obviously, competitors are not like sitting. They are also developing things. And as far as I observe, the industry is quickly moving towards kind of speed. This week or like previous week, there were some releases with some new fast models for Cursor, for Windsurf, and they really claim that they are very fast. We are more on the quality side right now. However, we are actively thinking on what can we do to compete with folks in terms of speed as well. Obviously, it will be using some more lightweight, more dumbier kind of models. And the main question is how to ensure that users are not disappointed when you are, for example, you are trying to solve some complex task and it just fails because it is routed towards a simpler model. So we are working on that. Hopefully, you will see really good progress soon. I can hear you, but your mic is off.
Okay. What kind of framework are you using for the analytics? Is it OpenAI SDK or for tracing stuff, something like that?
Yep, nice question as well. By the way, there is a blog post in the internet. You can search for Junie TeamCity, something like that. So we essentially are using TeamCity to run all those benchmarks. It's JetBrains' build system. And for analytics, essentially we have a quite big zoo of approaches to the analytics. So essentially, benchmark just dumps JSONs to some distributed SQL database. So we have a table that could be queried with a SQL, and you can download the logs from any run or from like a series of runs of benchmark. And then you have this huge JSON-L file, and you can do whatever you want. In our ML team, we do not have a single source of truth. While some folks are using, obviously for like very advanced analytics, everyone is using Python and some Python scripts, etc., to actually view the logs of the agents. There are different approaches, some like browser viewers or some custom viewers written in Python or whatever. So no single approach to this. Hopefully this answers your question.
Yes, thank you.
Sadly, we are running out of time, so I will invite you to find him during the break. You do get 15 minutes this time, so please be back on time.